So today I will be talking all about RAG. RAG has been one of my first project which I have done in AI domain, and it has single-handedly helped me crack many AI engineering interviews because RAG is common, and the problem which people face while building a RAG solution, that is also common. So in this video, I will not just only cover RAG, but I will also discuss what things you will face while productionizing a RAG-based application. And we will also touch some of the ways to solve those problems, along with when and when not to use RAG. That does help when you know the fundamentals and you have worked with customizing or optimizing RAG. People have started talking that RAG is gone, but in many use cases, you still need RAG, but a better version of it. So RAG stands for Retrieval-Augmented Generation. So let's understand RAG with an analogy of a library. So if you understand how library works, I think you more or less know how RAG works. Let's consider you have a problem to solve, which is algebraic equation, and you need some formulas, you need some understanding to solve that particular problem. You took that problem, came to the librarian, and asked for a solution. Now, librarian is not an expert on mathematics or algebra. He will just look at the problem, identify that, okay, this is a maths problem and looks like an algebra problem. It will go to the maths section of the library, look for books which covers algebra, and pick those books which would be related to your problem, collect it and give it back to you. Now you look inside those books for your formulas and theory, and then you form your answer. More or less similar kind of situation is happening inside a RAG. A query comes, then the query is looked or matched against all the knowledge available in that system, and if it could find similar kind of topics related to the query, it just collect those topics and deliver those chunks to form an answer. Then someone looks at those chunks extracted, make an answer out of it, and then provide back with reference to that particular section of the knowledge. This is important because of the requirement of grounding. Now, why would someone need RAG? The requirement lies in grounding to your specific knowledge base. If you have specific terminology in your business, which should be considered while answering a question, then I think RAG is better than just asking LLM. By just asking to LLM, it will have the context of all the internet's data on which it is trained on. But if you will have a RAG system, it will just focus on that particular knowledge base which you provide. So many companies have their own internal definitions, own internal knowledge which they want to focus and utilize to form an answer. That's when you will use RAG. Now I'll explain how it differs if you ask a question in RAG-based chatbot than a LLM-based chatbot like ChatGPT. So if you ask a question to ChatGPT, it has reference of all the internet data up till which it is trained on. If you ask a RAG, the usability lies in focusing specifically on the knowledge base provided to generate those answers. Since it has a given knowledge base, it forms better relevant answer than a generic answer. And also, since it have knowledge base, and if there is a requirement of looking for references from a trusted knowledge base, it is able to provide you the references as well. So that's where it becomes more useful. So mainly company uses RAG when they have to bind their answer on their own knowledge base, and also they want to provide the reference from where this answer is coming from, especially if you have internal knowledge which has those terminology which could be mistaken from general terminology if it is asked from a general chatbot. That's when your RAG system can help better. Simplest example of a RAG uses could be a frequently asked question chatbot where it has all the details of question asked and the correct answer of it. So anytime a customer asks a question, it goes away to the given document and answers a question back specific to that particular company. So for example, if you ask for a return policy, an LLM might or might not have that policy document for a given company. But if you specifically have given that particular knowledge base, it would be easier for it to look into that knowledge base and extract answer and also point you to right resources. Now I'll go a little bit more deeper into the fundamentals. So you have a knowledge base related with plants and gardening, and you have a question, how do I plant a rose? So all the knowledge base is converted into vectors and saved into vector database. And the question which is coming is also converted into vector and match against the vector database to retrieve those chunks. And then the generation happen based on the chunks retrieved. Now let's focus where you will have problem while deploying a RAG based system. Now the first problem which arises is if you have wrong set of document, you will always end up with wrong answers. So the first thing which should be kept in mind is the document which you ingest should be correct. If you ingest wrong document or outdated document, you are going to receive the same old answer which you should not get. So always make a priority to check all those documents either by yourself or by a domain expert. The second problem is sometimes just does not consider all the available knowledge about a particular question that is based on how you chunk. So mostly to make sense in a language, for example English, you have to follow how the natural flow of data is. So if you have a document which has a lot of paragraphs, bigger paragraph, and the information is such a way that the context lies in full paragraph, and if you chunk randomly based on words, it would not be able to contain full understanding of the paragraph. And if you chunk based on paragraph, it might be able to provide a better answer. Again, there is a balance in how much context you should take and how much smaller or bigger chunk you should make. It's good advice to follow natural flow of language with full stop, comma, and also considering headings, subheadings in your chunking. And also one thing which help is overlap. Experiment with different chunking methods and how much overlap you provide to get a better answer. Third is the metadata. So while you are chunking, you are also saving some metadata. For example, which page number this chunk belongs, which headings these chunk belongs, what are the document name, what is the version of it, when it was updated, etc. So if you have good quality metadata, it becomes easier for you to customize it. For example, there is a company which has two parts. One is technical, other is non-technical. And there is a requirement, sometimes you need to query both. Sometimes you need to query only non-technical and sometimes only technical. This filtering can be performed with the metadata you have, where you can add a tag to the chunks that this is technical part, this is non-technical part. That was just an example. So filtering would be possible if you have good metadata. If you want the page to open as a reference, for that to render that page, the page number would help you. Similarly, to filter on any document name, you need to have the document name saved as metadata. You can decide at the time of chunking what metadata is important for you. Those metadata will help you at retrieval. Now, another problem which comes is whenever the data is updated. So whenever a file gets replaced by a newer file, it should also update the vector database of it. So while you are building a RAG system, you have one data source where human can see the data, which is not chunked, which is as it is. And the other part is the vector database, which is in the number format and chunked. So whenever there is any change made to this, it should reflect in the vector database as well. So if something is added anew, it should get added in the vector database. If something is replaced, it should be deleted and updated in both the databases. There are a lot of chunking methodologies which you can experiment based on your requirement. It will give slightly different answers for different ways of chunking, and sometimes one is preferred over the other. So whenever there is a meaning-based question like what is ABC, it sometimes gets difficult to get it matched using semantic based matching. In that cases, keyword matching does work better. To make the retrieval better, the hybrid retrieval methods work well, where you combine semantic search with keyword matching. Another thing which you will find in RAG based application is the different type of unstructured data they want to utilize for the knowledge base. There would be PDFs, there would be Word, there would be Excel, and you need to find ways in which you render those files. Sometimes while you are just taking care of words, there are diagrams which get ignored in the chunking process. So there are many other provisions which you should take into account if your important data lies in your diagram, where you can add the vision extraction, which uses vision based LLM to understand that diagram, and you can add the understanding into word form if that is required, or you can keep that image saved, and in the retrieval you can just extract that image in the answer. Apart from hybrid search, you can also look into re-ranking of those chunks based on your own requirement. Sometimes it happens that the important information is retrieved, but it is not the first chunk in the list of chunks. So to give that important information a priority in forming the answer, you can have a re-ranking formula which, based on the question, it can give higher weightage to keyword search or higher weightage to semantic search. So RAG looks like a 3 or 4 step solution, but if we want to enhance answers and the retrieval, we can enhance that by adding additional nodes to the flow of the RAG system. Those nodes will act as a helping node for the next steps. AI system understands text better in a particular prompt format, but for normal user, they not always write their question in that particular format. So they can just simply write their questions and send it to a RAG-based chat to get their answer. And they will get their answer based on the similarity, and all the processing happens inside RAG. But to make their answer better, we can at initial stage add a step which rewrites the query better, understanding the user intent, and gives LLM a better prompted query which it will look and get the better suited answer. Those are a few ways which you can think of while you are facing any customization requests or issues with RAG. Now we'll talk about architectural upgrades which are done on RAG. There is one thing which is talked a lot about is knowledge graph. So it comes down to how good a data is understood. So knowledge graph has better understanding of data because it has relations. It understands relation between two nodes. So instead of a flat vector database, if you incorporate those relations as well, it would have better understanding of data. Places where knowledge graph helps is, for example, there is a company A which is subsidiary of company B. So if you have just flat vector database, it will, whenever you query about A, you will get all the information related with A. But if you have a knowledge graph where those companies are linked together, the retrieval will account that relationship as well while giving you answer. Anything where the impact of company B should also be looked, it will have the understanding by knowing the relation between these two nodes. And then there comes caching. So there are many frequently asked questions which can be cached. So it will be retrieved once and saved so that it can be quickly rendered whenever the same question is asked again. That reduces the latency and cost related to calling an LLM. Now, in this part, we will understand what else are related to RAG and where you should and should not use RAG. Use RAG when you have large knowledge base which cannot be fit into a single prompt, and it is changing. You need citations in your answer. There is a need of auditability, and the answer should specifically focus on the given knowledge base. Then you can definitely use RAG. Now, there will come a time while customizing a RAG, you will feel like your prompt has gotten way bigger and way out of control, and you have the requirement of specific tone and specific custom way of answering some question. That's when you should start looking into fine-tuning LLM based on the requirement. When you need specific output every single time in a specific rigid schema, that's That's when you should look for fine tuning, because fine tuning is changing the behavior in which your answers will be produced and not changing the knowledge base. When your RAG is confusing your specific technical jargons from general world knowledge, when there is need of specific output format every single time a RAG answers a question, that's when you should start looking for fine tuning. See if the results can be obtained by prompt engineering first before going to fine tuning. Again, fine tuning has cost implications. It could feel like with more context the answer will be better every time, but that does have a cost implication with it. Also, you should consider the decision of how much context you want to keep, and there could be the requirement of deep analysis where more context is required. Then you should decide on how much context you should provide in generating answer, and there could be a situation that only single sessions context is required to answer a question. So if you are just starting on building a RAG based project, here is my checklist which you should be thinking or looking at before building a project. The first thing is the data, how good it is, how frequently the data is refreshed, because a system where data is refreshed daily would need different architecture than a system where data is updated monthly or yearly. Always plan for updation and deletion in the vector database as and when something is changed in the knowledge base. Think about the chunking strategy. Spend time in trying different chunking ways and checking how the answer differs with different chunking methods. This is one of the most highest leverage decision you would ever make in getting good answer. Consider different kind of search based on the uses. It's good to have hybrid kind of search, and then you can play around the re-ranking methods of which part to give more importance to, whether it is keyword based searching or semantic based searching. Then again, prompt tune before you think about fine tuning, because many problems get resolved in giving a better prompt to the LLM where it understands it better, and you need behavioral change in place of just knowledge change, or understand the nuances of a company better, nuances of the jargons better than the general understanding. That's when you can think of fine tuning it. Metadata is again very important. When there comes more customization, filtering, or understanding of data, the metadata always helps. So plan for what metadata you will use while chunking and indexing of your chunks. RAG isn't just a buzzword to stand in an interview. It is one of the most practical, deployable piece of AI architecture. I hope this video gave you a better understanding of RAG, where it fails, how you can optimize it better, where you should be keeping your focus while planning for a RAG-based project, what are its requirements, what are other ways where you should start thinking about fine-tuning. So that's RAG from its basic to its deployment and what problem people normally face while deploying it in production, and some ideas on how do we cater on those problems. If this video helped you to understand RAG better, not just the definition, but where the actual problems come when you try to deploy it, and not just the ways how you can fix those problems as well, then let me know in the comment section. See you in the next video. Thank you for watching. Bye.